Welcome, class. Today we've got Unit 6, Day 2, so we've got 6.2 classwork to do. All right, the first thing I want to do is I want to go over the very last part of yesterday's classwork. So congruent shapes. So we know two things are congruent given two things. The two figures are congruent if they meet both the following conditions. So the first thing is they have to be similar, and the second thing is their side lengths have to have a common ratio of 1. And when I was talking yesterday about this stuff, this is kind of two parts. So we know their side lengths have a common ratio of 1, or, and I'm going to add this in, so or a side has to be equal. All right, perfect. So or a side has to be congruent. Because remember, if it's congruent, then when I divide them, it's going to be the same number divided by the same number. Like we can see here, 9 divided by 9 is going to be 1. So as long as they're congruent, then we know that their side lengths have a common ratio of 1. So in order to prove things are congruent, we need first them to be similar, and then their side lengths have a common ratio of 1, or a side has to be congruent. All right, so today's classwork, we're going to start with question 10. Review your work from problem 6.5, which required you to determine if the two triangles are congruent. Then work with your team to answer the questions below. And we can just answer the questions. So A, Derek wants to find general shortcuts that can help determine if triangles are congruent. To help, he draws the diagram at right to show the relationship between the triangles in problem 6.5. If two triangles have the relationship shown in the diagram, do they have to be congruent? How do you know? So remember, the first two things is we have to prove that the triangles are similar, and then we have to prove that at least one of the sides is congruent. So first question, are these triangles similar? Yes, they are. So yes, by side, angle, side, similarity. We've got this side here, we've got this side here, and we've got the angle in between them. So I can color my sides just like I did yesterday. So AC is going to be orange, which is going to make DF orange, since they both have one tick mark in them. We'll make AB yellow, which would then also make DE yellow, since they have the two tick marks. And then that leaves the remaining side to be blue. So that we have corresponding sides here. So the first thing is prove that they are similar. We did that. And the next thing we have to either say that a side ratio is equal to 1, or we have to say that a side is congruent. And we know that AC is congruent to DF. And we know this is congruent how? Good. We know something is congruent by the given if there's already tick marks in the picture that show us it. So I didn't have to use any math. I didn't have to do anything. All I did was look at the picture. I saw the tick marks, so I know that was given to me. So question B, write a conjecture in the form of a conditional statement or arrow diagram based on this relationship. If you write a conditional statement, it should look like if two triangles, ... then the triangles are congruent. What would be a good name for this shortcut? All right, so let's start off with if two triangles. All right, and there's my conditional statement. So if two triangles have two corresponding sides congruent, it's like we had orange was congruent and yellow was congruent, and the angle in between are congruent, so the angle in between orange and yellow are congruent, then the triangles are congruent. And we have to come up with a good name for this one. I mean, if you look, we used a side, an angle, and a side. So just like it was side, angle, side similarity, this is going to be side, angle, side congruency. We're going to call it SAS. All right, go ahead and go on to the next video, which is 6-11.